Hey guys, Travis here. Welcome to another uh, notes or another session. Sorry, it's been a while. I know that I should have probably uploaded this last week, and so I don't know if you guys feel like you got like an extra week off or something. But yeah, let's get right into this, guys. Now we're doing three dimensional, so we're gonna see if we can do a little review so we can catch you guys up and all that good stuff. So don't worry, we'll be fine. All right, let's go ahead and get started here. So this is coming from Mr. Forrester's notes. So I went ahead and put him in here. He was a pre-cal teacher and calculus teacher at Alamo Heights for many years, like something like 30 or 40 years. He's still around. He's a pretty cool guy. I actually got his signature somewhere on my textbook. So he's cool. Anyways, so this is from his text. Suppose that a helicopter rises 700 feet and moves to a point 300 feet east, 400 feet north of its original ground position, as shown in the figure. The position vector has three components rather than just two. So 300 feet east is like the x direction, east or west. You either move left or right. 400 feet north, so that's like your y direction. You either move up or down. And then it's 700 feet in the air, so that's your z direction. So you can see here, it's pretty easy to see. That's 300, and then you're going to go, see this, your ground is your x-y axis, if you call this the x and you call that the y. And then you're going to move 400 to the north, and then we move 700 up. So there it is. If they asked us to find what's the distance or what's the value of this, what's the magnitude of this vector, if they did, it's like Pythagorean theorem, but except we have three dimensions. You would say the square root of, let's see, 300 minus 0 is just 300, so 300 squared, plus 400 minus 0 is just 400, so 400 squared. And then you went up, so 700 squared, and the square root of all that. It's just like Pythagorean theorem, but in three-dimensional. So sometimes they call it, in geometry, they call it like the slant height or find the length of your diagonal. And I don't know if you can see it, guys, but it's really like finding diagonals of rectangular prisms. So let me see if I can draw it. I'm not the best drawer. Remember, I got a D in art. But I think I can put this one. Let's see. Come on, buddy. Let me draw a rectangular prism for once. Really awesome. Yeah, it looks like it's going to work. Let's see. There's my rectangular prism. There you go. Now there's my rectangular prism. I want the length from the origin to this corner specifically. So that's sometimes called slant height or diagonal. So this is how you find the magnitude. So see, hopefully you guys remembered that. So yeah, so there it is. I think that's pretty cool. Looks pretty neat to me, and I think we're good, guys. So there's some 3 videos that I have uploaded on talking about two-dimensional space, and then I'm just adding a third dimension here. So the third dimension letter that we're going to use is K, and that's for your z-axis. So x-axis, y-axis, and z-axis. And don't worry, we're going to help you guys. We're not just going to throw you guys out there to the wolves. It says draw a sketch of the position vector. So here, P stands for position. 3i plus 5j plus 7k. You can really, if you want to, you can say 3 comma 5 comma 7. And like always, that's your x position. This is your y position. And we're gonna call that the z position. Why do we call that z? Because it comes after the y, guys. Write the coordinate of point P at the end of the head of vector P. Find the length. Okay, so coordinate P, whenever you want to call a coordinate, you just use parentheses. So coordinate P, notice that I didn't put any vector or anything. It's just 3 comma 5 comma 7. So here we go, guys. How do you find this? Well, here's my y-axis. That's my z-axis, sorry. That's my z-axis. There's my y-axis. So this is my y. This is my z. And then to get the x-axis, you're going to make it kind of like at an angle here from the origin. Boom. And I'm going to call that the x-axis. If you want to put little dots, that's kind of like the back of your YZ plane. So hopefully that looks pretty simple to you guys from your geometry days. Hopefully. All right. So 3i. So 3 in the x. So I'm going to go 3. So there's 3. And then it says 5 in the y direction. So I'm going to go 5. So maybe I'm exaggerating, but there's 5. And then I'm going to go 7 up. So 7 up. I'm going to call that 7. So 7's here, but in a three-dimensional space. And here's my point P. And so here's my vector, or my position point vector, because it says position vector. So my position vector, boom, P hat. And there it is, guys. 3, 5, 7. No big deal. Write the coordinates of point P and then find the length of P. Okay, finding the length of P. So this is kind of like a rectangular prism, just like I told you over here. I'm not going to draw that anymore. I'm just going to go ahead and just find that out real quick. So the length of P is nothing more than the square root. And then the difference in x's, which is 3. So 3 squared, plus the difference in y's, which is 5. So 5 squared, plus the difference in z's, which is 7. 7 squared. What I mean by difference, guys, is that my height down here in the bottom is 0 and the height up there is 7. Now my y position here in the x-axis is 0. Here at this location is 5. So the difference between 5 and 0 is 5. And then the difference between 0 and 3 is 3. So if we were doing something else, then we would, well, do something else. We would find the position vector. So it looks like, let's see, 3 squared is 9, 5 squared is 25, 7 squared is 49. 49 plus 25 plus 9, I believe it's the square root of 83. And I don't know what that number is. It's like 9 point something, 9.1 or whatever. I'm going to leave it. It's some number. Who knows what that number is? This is perfect for me, so I'm good. And there it is, guys. That's it. I don't think we left anything. That's the length of P, so I think we're good now. Yeah, I think that's it. All right, let's keep going. Okay. Let's see. So this one says, find the displacement vector from point A. So I have a point A, and A is located there, to point B, and then B is located here. Use this result to find the distance between the 2 points. Okay. So I guess, and it's a vector, so I guess, okay, let's start. So here's my z-axis, here's my y-axis, and then here's my x-axis. So this is x, I'm going to label it, my y, and the z. So if you're having trouble visualizing this, guys, so let me go ahead. Don't worry, I'm not going to draw anything just yet, just listen. This right here is like, imagine this is a corner of a room. This right here is the corner, and then the z-axis is that edge, and then the xy is the floor. So the xy axis is the floor, and then the yz axis, this here in green, is one of the walls, and then the xz is another wall. So this is another wall. So hopefully that makes sense there, and that helps you with visualizing how to do these 3D. Let me see if I can just, oh man, is there a back button? Sorry guys, if it was kind of fidgety there, is because we had some a video edit go wrong. Didn't want to render video, so here we go. So sorry about that. So here's my y, here's the z-axis, here's the x-axis. So here we go again. Well, maybe for you guys it's the first time, but it's a second time for me. So 8, 2, 13. So I'm going to go 8 in the x direction, and then 2 in the y direction, and then 13 up. And I'm going to put a point. I'm going to call that A. So that is 8, 2, 13, x, y, z. And then 3, 10, 4. So point B, so I'm going to go 3 in the x direction, 10 in the y direction, and then 4 up. So I'm going to call that point B, and that is 3, 10, 4. So there it is. If you wanted to look at this vectors individually, so here's vector A, so little a with a little hat on it. And then here's vector B, so B with a little hat on it. And then the vector that they want, find the displacement vector from point A to point B. So they want this vector here. Notice it's going downwards, well, I guess kind of like in a downward motion. If you have two capital letters, A, B, those are points, put a little arrow in the top, and that indicates you're going from A to B. If you had BA with an arrow, that would indicate you're going from B to A. So we're going from A to B here, guys. So that's why I did AB with an arrow on the top. So here's my AB vector. Your AB vector. So let's see. I was at 8 and I went down to 3. So that means I went down -5. So that's how many units it was from 8 to 5. And then I was at 2 for Y value and I went up to 10. So that means I went up 8. And then I was at 13 and then I went down to 4. So that means you went down, what's that, 9? So -9. So there it is. There is my vector AB. And then it says, use this result to find the distance between the 2 points. All right, so this is my net change in the x direction. This is my net change in the y direction. So this is my change in the x, this is my change in the y, and then this is my change in the z, vertical motion. So to find the distance between those 2 points, we're just going to do like Pythagorean theorem, guys, but for 3 dimensions. So here we go. So I'll do a little line, and then this is like absolute value. And there's my AB, and I'm going to go square root. I'm going to go 5 squared. Chavez, how come you're not putting the negative? Well, the difference between -5 squared and 5 squared is the same thing. It's 25. The difference is 0, I guess, if I'm being technical. And then 8 squared plus 9 squared. If you want to put the negative here, that's fine. No big deal. 5 squared is 25. 8 squared is 64. 9 squared is 81. When you add them all up, that's the square root of 170. And I do not know what that is, guys. It's some number. You can leave it alone right there. So there it is. And if you're writing, units, you would put units. And that's it. You're done. All right, guys. Here's example 3. It says, find the position vector to the point 70% of the way from point A to point B in example 2. So we're going to start again. Same thing again like last time. There's my z-axis. There's my y-axis. Z, y. And then here's my x-axis. Little slant there. So this 8 is an x-coordinate. That 2 is a y-coordinate. That 13 is a z-coordinate. X, y, z. So again, let's see. 8, 2, 13 point. And I'm not trying to be perfect, but let's more or less try to, well, I'm not going to say try to be perfect, but more or less, just make a little estimate there. 3, 10, 4. So let's see, 3, 10, 4. So there's B, and that's 3, 10, 4. And just like last time, the vector AB is this one right there. That's not very good. Let me see if I can do it better. Point. No, you didn't lose the audio. I just trying to draw perfect there. So there it is. There's my vector AB. And we said vector AB was, let's see, what did we say? -5, comma 8, comma 9. -9. All right. And then what I want 70% of that vector. So the distance from here to here is 100%. So 70% is somewhere like right there. I'm going to call that point P. For vector P, and vector P is this one right there, little p with a vector on it. Okay, so how do I find that vector? Well, I need 70% of AB, so I'm going to find this one. Oh, I don't want to color code it. I'm going to go back to red. So I'm going to find 0.7 AB, and that's easy to do, guys. I already have what AB is, so I'm going to go 0.7 times -5, comma 8, comma -9. So when I do that, let's see, 0.7 times -5, and I get -3.5. -3.5, comma, 0.7 times 8, and I get 5.6, comma, and 0.7 times -9, -6.3. In case you're wondering where that 0.7 came from, guys, it said 70%, so 70% in decimal is 0.7. So there it is. That is my vector with 0.7 of AB. And what I'm doing actually is I need to add it to vector A. So here's little a. That's how I'm going to find your point P. So I'm going to add it to A. So see head to tail or wherever the arrowhead is at that I'm adding, just like we did in the other ones. Look at the other videos in case you forgot how to add vectors, guys. So what I'm doing is I'm taking vector A, and I'm going to add 0.7 of AB, and that's how I'm going to get vector P. Cool? Cool. All right, here we go. So vector A was 8, 2, 13. And then 0.7 of AB, I have it right here. So let's see, -3.5, 5.6, -6.3. And then we're going to add them component with component. So 8 plus -3.5, and I get 4.5. So vector P is 4.5, comma, and then 2 plus 5.6, and I get 7.6, or 7.6, comma, and then 13 plus -6.3, and I get 6.7. And I think that's it, guys. They wanted to know the coordinates of P. So I kind of have it already here. But if you want to be technical, coordinates of P is 4.5, comma, 7.6, comma, 6.7. And there it is. Yay. We're looking good, guys. We're looking good. All right, let's keep going. All right, example 4. Let vector C be -4, 6, and 3. Let vector D be 9, 8, and -2. And then it says find C plus D, C minus D, and D minus C. So before we even get started, guys, I'm going to go ahead and rearrange these. I'm going to say that -D, because remember, we're always going to want to add vectors. So I'm going to say -D is just the opposite of this. So I'm going to say -9, comma, -8, comma, 2. And I say -C is just the opposite of vector C. 4, -6, -3. All right, so here we go. C plus D. So vector C is -4, 6, 3, and we're just going to add a component and component, guys. X's with the X's, Y's with the Y's, Z's with the Z's. So -4 plus 9, what's that? 5, so 5, comma, and then 6 plus 8, 8, 9, 10, 11, 12, 13, 14, so 14, comma, and then 3 plus a -2, 1. So there it is, that's C plus D. And then they have C minus D, so vector C plus a -D. So that's how we're going to do it, guys. -D's up here. So let's see. -4 plus a -9. So it's going to be -13, comma. And then we're going to do 6. So 6 plus a -8. So it's going to be -2, comma. And then we're going to do 3 plus 2. 3, 4, 5. So that's 5. So there it is. And now I need to do D minus C. So we're going to go D plus a -C. And -C is down here. So let's see. 9 plus 4, that's 13, comma. And then 8 plus a -6, that's 2. And then -2 plus a -3, that's a -5. And that's it, guys. And it really is that simple. It's not even that bad at all. All right. So then this one says C plus D. So I already have that one. That one is this one right here. And I'm going to put a negative in front of that. So here we go. Negative. And then vector C plus vector D. So negative. And then 5, comma, 14, comma, 1. So I'm going to have -5, comma, -14, comma, -1. And there it is. That's it. So now it says 3C. So I'm going to write 3 vector C. So that means 3 times -4, comma, 6, comma, 3. So I'm just going to multiply them, guys. So let's see. -12, comma, 6, 12, 18. So 18, comma, and 9. All right, now that I have that, I also need 4D. So I'm going to, you know what? I'm going to make it a -4D. -4D. So -4. And then vector D was 9, 8, and 2 that I see up there. 9, 8, -2. So let's see. -36, comma, 4 and 8, 8, 16, 32. So -32, comma, and a +8. All right, I'm going to add them together, guys. So 3C plus a -4D is going to be, and I just add them, 36, 46, 47, 48. So -48, comma, let's see, -32 and 18. So 20 and 32 is 12, 14. So -14. Wait, did I do that right? 18, 28, 19, 20, yeah, that's right. And then 8, and is that a 9 up there? Yeah. What's that, 17? And there it is, guys. Hopefully that's correct. Let's keep going. It says find C and D here, so let's go ahead and do this one. So vector C, the magnitude of that is just the square root of, let's see, is it -4, 6, and 3. So -4 squared plus 6 squared plus 3 squared. So when I do that, let's go ahead, let me take my little calculator out, guys. 4 squared plus 6 squared plus 3 squared. I get square root of 61. Leave it alone. All right, D. So that's the square root of 9, 8, and 2. 9, 8, and I guess technically if you want to be technical, put the negative in there. 2. And why did I get those points, guys? Because that's the distance. That's the difference in x's, difference in y's, difference in z's. And if you're saying difference in what, Chavez, I don't know what you're doing. Difference in what? Difference in x's, guys, compared to the origin. 9 minus 0 is 9, 8 minus 0 is 8, and negative 2 minus 0 is negative 2, but you're squaring it, so it doesn't matter. 9 squared plus 8 squared plus 2 squared, and you get square root of 149. And yeah, let's just leave it like that, square root of 149. Okay, so to answer the first one, I'm going to put number 1. So number 1, C plus D is just square root of 61 plus square root of 149, and that's some number. You can leave it like that, guys. But if you want to, if you're like, no, Chavez, I want to put a number in there, you can write, let's see, you can write 20.0168, 0168. It keeps going forever, but you can write that if you want. All right, C plus D. Well, we already have that one. C plus D is this one up there, 5, 14, and 1. So here is number 2. So I'm going to put number 2 here. So number 2, C plus D is the square root. Oh, what's going on here? Okay, get out of there. Is the square root of 5, 14, and 1. So square root of 5 squared plus 14 squared plus, and if you want to be technical, negative 1 squared. And that is, let's see, 5 squared plus 14 squared plus 1. Square root of 222. Square root of 222. All right. Did I just do, okay, it says, does CD plus D equal, and then the answer to the question is no, they don't equal. Done. All right, what do we got next? Ooh, unit vector. Unit vector. Find a unit vector in the direction of D. Find a vector 10 units long in the direction of the opposite of D. All right. Hopefully this makes sense to you guys. This is new. A unit vector means that I want the vector to have a magnitude of 1, because that's what 1 unit is. So I'm going to write want vector to have magnitude of 1. And that's actually pretty easy to achieve. So let me write what vector D is at the moment. Vector D is 9, 8, negative 2. Whoa. Sorry, my laptop's acting fishy, guys. 9, 8, negative 2. So in order to make this vector have a magnitude of negative 1, so I'm going to call U for unit. So here's my unit vector. If I want my unit vector to have a magnitude of negative 1, I need to take my vector D, and I need to divide it by the magnitude of D. And that will definitely give me a vector with a magnitude of 1, because look, you're dividing by itself. But you have to do it each component at a time. So first, we already know what D is. It's the square root of 149. So the magnitude of D is the square root of 149. And to get vector D to have a magnitude of 1, so here's my unit vector. My unit vector has to be, so I'm going to take the 9 and I'm going to divide by the square root of 149. 9 divided by square root of 149, comma. I take the 8 and I divide by the square root of 149, comma. And I take the negative 2 and I divide by the square root of 149. And let me see if I can show you guys visually how we know for a fact that that's going to be a magnitude of, how do we know for a fact that that's going to be a magnitude of 1? So let me see if I can grab the calculator here. Yeah, this one will work. I'm still in the trial version, guys. All right. And I have my TI-84 here, so my bad, guys. But look, check it out. I'm just going to move this to the right, and I just want you guys to see this. So sorry if we're taking forever here. So watch. If I write in parentheses, I'm going to parentheses 9 divided by square root of 149. And I'm going to get out of there, and I'm going to close that whole shebang, and I'll put square on it. Because I'm finding the magnitude of that, right? I want to make sure that it's 1 divided by 8 divided by the square root of 149. And I'm going to get out of there, and I'm going to square that again. Plus, and then open parentheses, -2 divided by square root of 149. And we're going to get out of there, and I'm going to put square. So if I did everything correct, when I push enter, I better get 1. Now, if I don't get a 1, it's going to be an epic fail. There it is, guys. So I got my magnitude of 1. Man, isn't math beautiful? So there's my unit vector. Now what do they want me to do? So here's my unit vector u. Find a vector 10 units long in the direction of the opposite of d. Find a vector 10 units long in the direction of the opposite of d. Okay, so they want my vector to be 10. So since this vector already has a magnitude of 1, this is already my unit vector. All I got to do, if I want opposite, that's multiplying by a negative. And if I want it to be 10 units long, all I got to do is multiply by 10. Yay! So look how smart you guys are. So all we got to do is my new vector is just -10 times my u. And that's it. That's all you're doing. So here's my new vector, guys. So I'm going to write, I'm just going to multiply all these numbers in the top by 10, -10. So -10 times 9 is -90 over the square root of 149, comma, -80 over the square root of 149, comma, and then +20 over the square root of 149. And then close it with your chevron. Yay! All right, guys. I hope you guys feel empowered. Let's do one more. The next problem I think is going to be fun. I hope you guys like it. And we'll see. Here we go. Delmer builds a treehouse in her level backyard for her to grade papers and get work done. She uses one corner of the yard as the origin of a three-dimensional coordinate system, so that means the xy plane is going to be the ground. The x-axis and y-axis run along the ground, and the z-axis is vertical. The treehouse is at the point 30, 55, 17, where the dimensions are in feet. Sketch the coordinate axis on the point 30, 55, 17. Okay, fair enough. Fair enough. So here we go. That's the z-axis. There's my y-axis. There's my x-axis. X, Y, Z. So 30. So I'm going to say this is 30. And then I'm going to say 55. So I'm going to say this is 55. And then 17. So I'm going to say that's 17. So there it is. That's my point 30, comma 55, comma 17. And we're done. All right, write the position vector h to the treehouse. Okay, position vector, let's do it in green. So here's your position vector, and we're going to call that h with a little hat on it. How high is the treehouse above the ground? Well, so the xy plane is the ground, so that means you're 17 feet high. So I'm going to say treehouse is 17 feet above the ground. Yay! And then how far is the treehouse from the origin? All right, well, from the origin, it's like a rectangular prism here, and it's like doing Pythagorean theorem. We can't really call it Pythagorean theorem because that's a property for two dimensionals, but it's like Pythagorean theorem. So we're going to say, let's see, magnitude of h prime is the square root of 30 squared plus 55 squared plus 17 squared. And let's see what we get. 30 squared plus 55 squared plus 17 squared. I'm going to push enter. It's a square root of 4,214. I have a smart calculator here with me. So if I go 4214, it tells me that it is 7 square root of 86. That doesn't really help me. I'm going to go ahead and do what the actual value is, 64.9153, and I guess that's technically the approximate feet. Okay, I think we're good, guys. All right, a little bridge for cats is built from the treehouse to the point 1008. Okay, I want to visually see this point, guys, so I'm going to come over here and I'm going to write where 1008 is at. Oops, sorry. So I'm going to, let's see, I start at the origin, so 10, 0, so I haven't moved anything, and then 8. So 1008. So I'm going to say it's like, well, it can't be 1008. And it looks something like, well, there it is. That's my, that's where it terminates. All right, which is the edge of Domer's roof. I saw a cat chilling. Okay, whatever. That is the true state. I did see a cat chilling today, guys. That's what inspired this question. Write a vector representing the displacement from the treehouse to the edge of Domer's roof. All right, so they want this. Let me do it in red. They want from here to that point. And my calibration is a little off, guys. It's been off all this week, so my bad. So yeah, so let's go ahead and go from the, so let's see, vector 3315. So I'm going from the treehouse, 33, man, short-term memory. It's not even 33. Man, that is so lame. 30, 55, 17. And I'm going from that to 1008. And I guess we should give this a name. I guess this is point H, and I guess just going down the alphabet, I'll call that A. So my vector HA, that's what they want. It says write a vector representing the displacement. So my vector HA, I was at 30, now I'm at 10. So that's negative 20. I was at 55, now I'm at 0. So that's negative 55. And I was in 17, and now I'm at 8. So what's that? 8, 9? 9? 9. Negative 9. Ooh, I don't want to mess up there. So there it is. That's your vector hop. What else do they want? Write a vector representing this displacement from the treehouse to the edge of Domer's roof. All right, there it is. I don't see that they want anything else. All right. How long is the little cat bridge? Okay. Well, there's my x component, or the change in x. There's my change in y. And there's my change in z. So I can find how long this cat bridge is by doing the magnitude of HA. So let's see, that's a square root of negative 20 squared plus negative 55 squared plus negative 9 squared. And we get, let's see, 20 squared plus 55 squared plus 9 squared. So I get the square root of 3506. And the square root of 3506 is 59.2115 feet. That's how long it is, guys. All right, let's see what we got next. There's a sleeping cat on the little bridge 30% of the way from the treehouse to Delmer's roof. Write a vector representing the displacement from the treehouse to the cute cat. How far along the bridge is the cat? Okay, well, it should be 30% away of this number here. So we'll verify that in a little bit. So let's first do that vector, guys. So let's see. Let's do 30% of HA. So the 0.3 is the 30%, guys. So 0.3 times my HA. So negative 20, negative 55, and negative 9. So let's see what that is. So I get 0.3 times 20. Well, that one's simple. That's just 6, right? Negative 6. And then 55 times 0.3, so negative 16.5. And then 9 times 0.3, so negative 2.7. All right. So I should, let's see, 0.3 of HA. This should be the same number as 30% of this one up here. So we're going to find out. we're going to find out in a little bit, guys. Negative 6 squared plus negative 16.5 squared plus negative 2.7 squared. And let's see what we get. So 6 squared plus 16.5 squared plus 2.7 squared. So I get the square root of 315.54. And so square root of that number. And I get 17.7634. Let's see if we're correct. It looks like we're correct, but I'm not sure. So let's see. Check it. Check. 0.3 times 59.2115. 59.2115. 0.3 times 59.2115. Yay! We're correct, guys. Let's see. How far along the bridge is the cat? Okay. So I'm going to write the cat is 17.7634 feet away from the treehouse. All right. Write the position vector of the sleeping cat. So that means my vector initially, h, and I'm going to add the 0.3 ha. H was initially at H was initially at 30, 55, 17. And I'm going to add the 0.3 of hot. So I'm going to write, so here we go. So 30, 55, 17. Did I get that right? And then 0.3 of ha, and I got negative 6, negative 16.5, negative 2.7. And so that's going to give me where I'm at now, my new position, if you want to think of it like that, guys. 30 plus a negative 6, so that's 24, comma, and then 55 minus 16.5, so that's 38.5, and then 17 minus 2.7, so 14.3. How high above the ground is the cat? This one right there. The cat is 14.3 feet above the ground. Yay! Cool question. I liked it. He has 4 eyes. Oh, now it looks weird. Alright, too bad. Oh, now it looks like a devil. Okay, you know what? Whatever. Hopefully you enjoyed this, guys. Hook me up with a thumbs up. Sorry if the commentating wasn't all that awesome. But yeah, hook me up with a thumbs up if everything was okay with you. Let me know if you find any errors, extra points if you find errors, guys. And if something was confusing, put a comment, and I'll see if I can get back in and answer your question, guys. All right, I guess that's it for today, and then just take care of the assignment that I uploaded, and we'll have a quiz on this pretty soon, guys. The quiz will be pretty simple, so it's about as hard as it's going to get. Maybe we'll talk about the dot product and cross product. I haven't decided yet. So maybe we'll do one more, maybe not. So we'll see, and we'll just go from there, guys. All right, talk to you guys later. Bye-bye.